Okay, we're moving on to 16. So it says the year 2001 was clearly, okay, we're still talking about the accident thing. If the data for that year are reduced by 4 fatal accidents and 265 fatalities, which of the 3 measures change, and what are their new values for each of the following? So 2001 was in terms of fatalities, let's see, what are we talking about? We're talking about 2001. So that's 6. So that's much higher than everything else. So what's going to happen is 6 will change to 2. And the number of fatalities will be decreased by a considerable amount. So what happens, and we're talking about fatalities here, so the new set of data will be 2, 2, 2, 0. Okay, they're asking about fatal accidents. Okay, so we're in the right one. 0, 2, 1, 3, 2, 0, 0. So what happens is this was 6, and it went down to 2. And if we order these originally, so we'll do the original ordering. So what you'll have is, so what we're doing is we're doing everything this way. So we have 0, 0, 0. So those are the 3 zeros. We have 1, 1. We have 1, 2, 3, 4 2s. We have 1, 3, and a 6. So let me make sure I got the same number. I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So in this case, the mode is 2, and the median, because we have 10 numbers, that's even. So the 2 numbers that we use for the median is the average of these 2, which is going to be 2. Now, if we put a 6 in there, what will happen is we replace the 6 with another 2. So it's going to be, we're going to have 5 2s and no 6s. So that's what it looks like. This 6 becomes a 2, and the 3 moves over to the end. So again, the mode is still 2. It's even more of a mode because it's 5 here, we had 4 there. So the mode is the same. And as far as the numbers used for the median, 1, 2, 3, 4, 5, 5 and 6 are these 2, same as this one. So the median stays the same. So the only thing that changes is the mean. And the mean for this part is going to be 0 plus 0 plus 0 plus 1 is 3, 1 plus 2 is 3, 5, 7, 9, 11, 14. So it's 14 divided by 10, which is 1.4 is the mean. And with 6, the mean would be higher. It would actually be, what would be the original mean? Well, we don't have to add them all up, we just have to think about what's changed. So the difference from here to here is 4 less, so the original mean should have been 1.8, and that's correct. So what does this tell you? It tells you that one outlier, unusual year, can throw the mean off considerably, change the mean, but the median and the mode don't get unchanged. So that's kind of an advantage of the median and the mode. They're less affected by outliers, meaning data points seem significantly different than the other ones. Okay. Student from exercises 19 and 20, when reviewing the calculation later, decide that the entry 22.2 should have been recorded as 2.22 and made the changes. So they're asking for the new mean. So we're not going to go through the whole calculations, but we'll put this in context. So 19 is the mean of the numbers, and because we have one large number, the 22.22, it turns out the mean is 5.27 seconds, whereas the mean is the average, whereas the median turns out to be 2.39 seconds. So that's equal to the median. So when you remove that one bad data point, what you have is you have 2.16. The number's 22.2. Actually, that's the incorrect entry. 2.22, 2.96, 2.20, 2.73, 2.38, and 2.39. 1, 2, 3, 4, 5, 6, 7. So there's 7 numbers. So the mean with the corrected data point is going to be. So we add those numbers together. So the sum of all those is 17.06 divided by 7 data points. And I get 2.44. Did I write something down wrong? Because I'm not getting exactly the right number in the book. 2.73. Okay, maybe that was it. 2.73, not 2.75. Okay, divide by 7, get 2.43. Still getting a slightly different number. Oh, yeah, I figured it here. Put in 2.38 instead of 2.28. Okay, now divide by 7. Oops, divide by 7. Yeah, there we go. So this numerator is not actually 17.06, it's 16.97, 16.94. And so when you do that, you get 2.42. So again, you can see that and if you do the median, which I'll leave that up to somebody else to do, but we'll do the numbers, you get 2.28. So you can see the median changes very little because of this error of using 22.2, whereas the mean changes significantly. So if your mean and your median are significantly different, you might want to look at the individual data points, because there may be one data point that doesn't fit with the rest of the data. You don't want to just ignore it, because you can, you have to think about, is it reasonable to ignore it? Okay, we have scores on the management exam. We have 6 scores, and they want to find the mean. Well, we'll do 25 as well. So let's do 25, just because they want those numbers. Find the mean, the median, the mode. Okay, so I'm going to order them first. 44 is the lowest number. 79, 79, 81, 89, 90. Okay, so the mean is sum of the numbers. 44 plus 79 plus 79 plus 81 plus 89 plus 90. And I get 462 divided by 6, because there's 6 numbers. I get 77, which makes sense. Okay. So that's the mean. The median is going to be, there's 6 of these, it's going to be the sum of the average of these two, so the median is 80. And the mode equals 79, because there are 2 79s. Okay, so that's the statistics. Then 26 says, which of the 3 averages probably is the best indicator of Rob's ability? So probably his median is the best, because the mean has that one bad test, and all the other ones are more consistent. So, you know, everybody has a bad day, and so you could possibly drop that. Even so, the median is only 2 points less, or 3 points less than the median, so it doesn't throw it off completely because it's only 1 out of 6 tests. So even using the mean, it's probably a reasonable estimation of his abilities. The mode being 79 is kind of a coincidence. You know, the fact that you get 2 to have the same value, most likely you're not going to have 2 of the same value. So the answer to 26 is the median. Okay, we'll stop there.